So here I am back in the workshop with more broken quads. I wasn't going to YouTube this, hence I'm halfway through the job, but I've actually discovered a very interesting breakage I'd love to share with you guys. So on the left we've got my old faithful 06 350 Honda Rancher. Absolutely love this thing. I have put crazy miles on it, given it insane abuse, and it has been very, very reliable until lately. Things have just started to break one by one. I'm starting to get very sick of putting CV joints into it, and bearings and rear diffs and just all the usual Honda things. Not slating Honda, I'll say the usual Honda things. That's like after 15 years of heavy duty, severe recreational abuse. So yeah, the current breakage, front diff. I fitted this bike with a Detroit gearless locker in the front diff. As you can see, the front diff's currently missing. That's because it's lying on the floor. I have taken the internals out of it, and they're over in the bench here. So, as I was saying, I fitted a Detroit gearless locker into it, and what a fantastic piece of kit. When the bike is in two-wheel drive, I fitted a two-wheel drive selector as well. They were originally four-wheel drive from the factory, so I fitted a two-wheel drive selector and a Detroit gearless locker, and that meant that I could drive the quad in two-wheel drive, and then when I selected four-wheel drive, not only was it four-wheel drive, it was four-wheel drive with a locked front diff. But whenever it was in two-wheel drive, the Detroit gearless locker unlocks, giving you normal light steering as you would expect from an unlocked diff, and then select four-wheel drive and you had total front diff lock, rear diff lock, and true four-wheel drive, and the little bike was absolutely unstoppable in true four-wheel drive. However, just recently my Detroit gearless locker stopped locking. I know they have like a shim face that will probably eventually wear, and cone washers and things. I'll take it apart and show you in a minute. But I toyed with changing the oil because you have to put a slip additive in. So I messed around with ratios of that, still no luck. I took the diff out, took it apart and looked at it. I couldn't see any real wear. I didn't have any specs to measure. I looked at the cone washers, and there wasn't really any way of shimming them up with anything I easily had available. So I just cleaned it thoroughly, put it back together, and it worked occasionally, to say the least. So went from occasional to absolutely not working at all. So the worst part about it not working at all meant that not only just having an open front diff, it actually wouldn't engage any drive to the front wheels at all. So essentially the quad was two-wheel drive, and a two-wheel drive quad, purpose designed, will completely outperform a four-wheel drive quad in two-wheel drive. Because of the weight distribution, four-wheel drive quad in two-wheel drive is quite nose heavy, so they can't grip very well in the back. So absolutely just couldn't live with it, nightmare. So once again I've had to pull the diff out of it for a look to see what I can sort out, and to see why it has completely failed, not working at all. And I was greeted by this lovely little surprise. Lovely. So I know, given its serious abuse, I'd spun heavily on ice when the front wasn't locked, and then the Detroit gearless locker would finally grab with a bang when the wheels were spinning at speed. So I wasn't that shocked to see this. However, first impression, I'm looking at this, I thought, yep, the drive, the half shaft has sheared this off, twisted it off. And then of course it occurred to me, well, there's no splines in this. Splines are on the inside. So I was like, flip, how did that break? So that little ring you're looking at is in fact a thrust ring. And what has actually happened is, whenever the Detroit gearless locker operates on a wedge separation force, a thrust force, and it exerts a thrust force onto that washer below this, and it has simply burst, actually pushed that off from the inside, burst it out. So I just thought that was a fascinating failure, and at this stage I've actually got nothing to lose, so just thought I'd try this and bring you guys along for the fun. I thought, what the heck, nothing to lose. I'm going to weld this back on, and there's no space restriction, so yeah, I can put lots of weld on. Now, how successful it'll be, I don't know. It appears to be like a strong, fine grain forged item. It looks like it's been stamped in a big hammer, a big press or something. So I expect the weld, I don't know how well it's going to take to it, but what the heck, I'm going to put lots and lots and lots on, weld it at a high power with good heat, good fusion, good burn-in. I just have to decide on the filler material. So yeah, I'm going to go and do a bit of homework, figure out what wire to use, weld this back on, reassemble it and try it out. Nothing to lose. And there's probably other Detroit gearless locker owners out there that have suffered this failure, might like to see how it pans out, whether to bother repairing it themselves or not. So yeah, we'll weld it up and put it back together and see what happens. So stick with me and we'll get the welder fired up. First we'll give it a preheat. So we can see color on there. I know it's more than hot enough. I'll just give it a little tack now. Okay, so now I know it's tacked tight. I'm going to take it out of the vise and fully weld it. So many things that cannot go right with this repair, but absolutely nothing to lose, so why not? Still absolutely roasting hot. Yeah, it's well over 150 degrees. So I'm going to give it lots and lots of weld. And the most difficult part of this will be stopping any spatter getting onto the gear teeth or this outer bearing surface. So I'm going to put some anti-spatter onto those. I just use this tip. I find it very, very effective. It just puts a little waxy layer of protecting material on there. All the little gear teeth as well. It's hard to pick up on camera, but it's melting down onto all of the surface. I've used this tip for years and years to protect the chrome on hydraulic rams, and I find it super effective. So now that's it protected and preheated, it's time to weld it up. So the next tricky bit will be getting a good earth without causing any surface damage. So I've screwed this bolt into the bottom. I'm going to attach the earth onto that. So that's it clipped onto the earth, onto that bolt. The next part will be keeping an eye on overall temperature or interpass temperature. So I'm going to do a few runs, let it cool down, because if it exceeds 350 degrees centigrade, it will lose any of its tempering. So this is a forged steel. It's probably got a reasonable carbon content because it has machined gear teeth on it, which have been hardened, given a very hard, long lasting wear surface. So I don't want it to get too hot and affect that temper. So yeah, put some runs around it, let it cool for a minute. I reckon that's already over temperature, so I'm going to let it sit for a minute. I'm going to get the laser and check it here just out of interest. So there you go, we're just on the absolute limit. So I'm going to let that cool. I'll maybe turn the welder down a little bit. I just wanted lots of power for that initial fusion penetration. So now I can turn it down a little bit. I'll do some slightly cooler multi passes to cap it off and bulk it out. So just a waiting game now. I love these little experiments where I've got nothing to lose. You know, it's already broken, so nothing really worse can go wrong. So yeah, just try it out and see. Fairly confident it should work, purely because there's so much scope to put a lot of weld onto the broken area and strengthen it up, so providing heat doesn't affect the metal too much, should be okay. So yeah, just waiting for it to cool after that second pass, and we'll put the third pass on. And there we have it. No way that's popping out of there again. That was a crap ton of weld. She'll be hot after that. Not bad. Yeah, the metal's in excess of temperatures, but the outside's perfect. So yeah, I'm very happy with that. Gonna let it cool now. Gonna let it cool slowly. Put some old welding gloves I keep for these reasons, just to stop from cooling down too quickly. So yeah, we'll have a look at it, check the machine surfaces after it cools down, and start to reassemble it. Hopefully it does reassemble. What's it cooking? Some old cowhide. Not like a stink of burning leather. So yeah, we'll just let her sit in there for an hour and come back after lunch break and see what it looks like. Phew-wee! So this is the little Detroit unit itself that bolts onto that crown wheel on this flange. I've actually discovered the locker itself is broken, but as usual in my cheapskate ways, I'm pretty happy it should be okay. Very smart how this little item works. So what you're looking at there, this little multi-plate clutch pack. Whenever those are squeezed, they deliver drive through this inner spline piece, which is what your CV, your drive shaft, drives from. So in order for the drive to go to the drive shaft, these have to be squeezed tight, locking them up into direct drive. And how they are squeezed tight is through a very simple, very clever little cam design. So you see those little V grooves? They sit over that pin, and whenever that pin turning force is exerted on it, whenever the outer diff housing crown wheel turns this body, turns these splines, turns this pin in that direction, that pin turns in this V groove. Because that V groove is essentially a cam ramp, the pin rides up this ramp and pushes this outward, and as it pushes this outward, it's this face on the inside that works against these little clutch packs and squeeze them solid. That then delivers drive to your drive shaft through those splines. Very, very simple, clever little design. So this little face here, which squeezes the back of the plate, is under immense force. It's working under the leverage of that ramp, which is essentially a wedge. That wedge pushes this out, squeezes that, but of course that means the other side of these plates have to push against something. What do they push against? They push against that shoulder that is now broken out of the crown wheel. So absolutely incredible, the squeeze force that is exerted there. Like, honestly, I don't think I could burst that out of there in a 10-ton press. You really could be talking over 10 tons of force exerted by this little ramp. Now, that only takes place under circumstances of pure and utter abuse, which was the case with me. I was spinning all the wheels at high speed, maybe third gear on ice, and it was only then, because I don't have the right additive or there's wear, that the plates eventually started to grip, which caused this to ride up the cam and lock them solid. When it does that in milliseconds. So you have axle shafts, drive shafts doing full revs, third gear, turning speed, and that instantaneously locks up in a millisecond, delivering enough force to break the diff. So that's the resulting damage that we have now. So yeah, weld the crown wheel and put it back together. You know, just looking at it again, it really is astonishing that little clutch pack is what drives that entire wheel. Absolutely incredible. Incredible. How does something of such small diameter drive something of such large diameter? The mind boggles. It's all to do with the combined surface area of all of those little plates. 1, 2, 3, 4, 5, 6 of them. So 6 times those rings, both faces. Still hard to imagine how you wouldn't have an area much larger than the palm of my hand in total surface area expected to drive that wheel. But it works enough. It works enough to provide enough force to burst the diff. So yeah, incredible. And I have to say, it was a really fantastic unit up until the stage that it broke or wore out. It gave me probably 4 or 5 years of very good service. Just now it's probably worn out. These plates are probably worn out. It's probably due some sort of factory service. But sadly I think this is discontinued. So if this doesn't work, I'll have to go back to the standard diff, or put a lunchbox locker in it, which means permanently locked front diff, which means hideously heavy steering and sore arms. So that's why I'm willing to try this first. So let's check the oven. To put more on or not, I'll pick it up and see where that outermost diameter weld falls on this other side. No, I think I let that go at that. So I'll just give that face a little wire brush. A little scaly, and we'll put her back together. So this is the stage where we run into our first problem. With this ring being welded, the natural conclusion would be that that spigot would shrink. So this diameter here is the bearing fit for this bearing. The natural assumption would be that this would shrink down a little bit, which we wouldn't exactly want, because it needs to be a good fit in this bearing to ensure good mesh between this gear and this gear. You don't want to lose fit. Tried to fit it onto the bearing and it will not enter. So rather than shrink, what I think has taken place is it has actually went slightly out of round. So that used to have been round and it now must be egg shaped or oval, whatever, so slightly warped. So that leaves a couple of options, probably three options. I could confirm and look with a micrometer. I might actually just get a digital vernier and check it for interest sakes. You could possibly put this in a lathe and clock it up and machine it back to round, but more than likely it'll be slightly undersized. I'm not going to go to that trouble because A, it'll be such a minuscule cut, it'll be very difficult to attain, and B, I still don't know if this is going to work, so it's just not worth going to that effort. So the next option is either heat this bearing to give me more clearance to let it enter, or freeze this gear to get it entered. As I'm lucky enough I have lots of liquid nitrogen here, I'm just going to set this into a little tub of liquid nitrogen and shrink it down to size, hopefully a clearance size that it will just simply drop into that. And then when it comes back to temperature, we'll just give it a spin to ensure that the bearing hasn't went out of shape and still spins freely. So we'll do that, we'll freeze it, hopefully put it in and see what it feels like. We'll just grab a vernier gauge, digital vernier gauge, and measure this for a bit of fun. So let's see what a good old eBay verniers say. 28.91 millimeters. Turn it 90 degrees. 29.04. That's where you really need to set a micrometer for an accurate measurement. I'm going to set the camera down and use both hands for a second. So yeah, we're 0.02 mil oval. So 2/10 of a millimeter. Which yeah, it's a bit. It's enough for a bearing fit. 0.02. What's that in imperial for our American friends? So yeah, 0.02 mil is 0.001. So what's that? 1 thou? 1 thou. If that's correct, I have no knowledge of imperial, but say call it 1 thou, which the bearing should be more than able to deal with. And some of the big bearings we have 3 thou clearance, so 1 thou, that should be okay. But anyway, we'll freeze this up in some liquid nitrogen, and hopefully it'll drop into the hole. 0.02 of a mil. The liquid nitrogen should bring that down, and it should drop right into the bearing. So yeah, let's go and do that and get her together. Stop talking about it as usual. Should be pretty cold now. You can see the gear oil is frozen solid. I'm gonna put on my gloves and try and lift it out of there. I'm not going to waste time measuring it. Just going to put it straight in. Unbelievable. That is just glorious. Absolutely glorious. The way that slipped in there. Absolutely glorious. Let's get nice frozen gear oil stuck to it. It's quite hard to turn because of the frozen gear oil. It's currently probably minus 150 degrees. So there we've cryogenically treated the weld after welding it. So that's it, loosely assembled by hand. As you can see, the crown wheel's still frozen solid. So I just still want to nip up the bolts until that has came back to room temperature. Turning lovely and smooth. This is an absolute prick to reassemble. All the little shims and sleeves and splines, and they all want to fall out of each other, and they all have to be lined up, and you have to turn it over to put it on, and they all fall out, and yeah, fiddly. I should have time-lapsed it or something, but yeah, I just wanted to get it done. So, guts all back in the gearless locker. As I said, I don't know if this is going to work, but although it was worn, it was still able to grab enough to burst it. I'm hoping there's enough life left in the plates with that shoulder that was burst out. Now put back to where it was. I'm hoping it should operate. Yep, they're tight. Quite impressed with these Milwaukee tools. Absolutely no paid promotion. I just got this. And 3/8 drive impact gun. And that was a set on number 2. And yeah, I cannot tighten it any tighter with a spanner. So yeah, very pleased with that. Nice little lights. I like to see what you're doing. So yeah. than happy with that. Time to stick it back in the quad. It's going to be fun. I have the good old Warren 242 disconnect drive shaft to get in, and we have the drive shaft on the other side to get in at the same time. So gonna need arms like an octopus for this job, but we'll bodge it in there some way. Unbelievable. Check the other side. I can't believe that. I've got four-wheel drive back, I'm so happy. Oh man, I am so happy. So here we are. It's been very rainy here the last few days. We're in two-wheel drive. That's us, so let's stick the Warren 242. I can't believe it. We have a locked front diff again. Oh man, I can't believe it. Over the moon. Absolutely over the moon. So yeah, I'll run it for a few weeks, months. Well, probably a few weeks because I want to get this video out. So I'll run it for a week or two in the mud and see if it stays locked. And let you guys know if there's any failures. Yeah, been a lot of rain here recently, the little waterfalls flowing. Oh, spring's coming. Damn, it's nice to get out in the fresh air. So yeah, unbelievable guys, over the flipping moon. I've got four-wheel drive again. I wanted to change these boots. As you can see, they're torn. They're eBay CV joints. Quite disappointed in the quality of the rubber boots. These CV joints are like they're probably about 6 months old, and they're all split already. So yeah, don't really recommend them. Try and go Honda, genuine Honda if you can, because the rubber that's rubbish. So I'll have to change them at some stage. I didn't have any. I just want to get this together and get it out and try it. So yeah, anyway, successful experiment so far, and lots more riding and playing and mud videos to come. So yeah guys, ooh, too much coffee. Oh, lightheaded. Whew. So yeah, absolutely over the moon. If you enjoyed that little video and a bit of information, I hope it was some sort of help for you. Check out my other videos of loads of others, quad fiddling, mechanicking videos, lots of other videos of tractors and 4x4 and off-roading and welding and engineering. If you like the engineering part of it, check out my other engineering videos, and I appreciate you guys tuning in as always. So yeah, I'll try and get some more videos up soon. Catch you soon. Thanks very much, guys.